Okay, new thing for today is this is lesson 5.1, and reflectors drop working, great. Standard form versus slope-intercept form versus point-slope form, basically a whole bunch of ways to write lines. These are families of functions is the kind of title of this whole chapter, and I'm going to show you some examples of these. If I said, here's 2x plus 5y equals 7, do you know what form that is of a line? Standard form, good. That's standard form. You have x first and then y and then a number. It's really handy for matrices. Last year you learned how to put these things into matrices. Like, let's say I had another one. You could make a matrix out of this. Do you remember? And you'd say 2, 5, 3, 6 was the matrix. Does that ring a bell? Anyway, that's one thing you can do with standard form. There's a whole bunch of other things too. But all right, so what's another form? Another form is this one that you did 8 million times at the middle school. I know because I taught there for a long time. You learned this over and over and over and over again, and it was what form? Slope-intercept, because it's got the slope right there, and it's got the y-intercept right there. Okay? So don't be fooled when it's just backwards. What's the slope now? 6. And what's the slope now? -6. And one more complication. What's the slope now? I'm hearing a lot of different answers. Okay, -6/2 is a correct answer, but couldn't you simplify that a bit? -3 would be the slope on that one. Okay, good. So then there was this form of an equation. They might know the name of it. Point slope, very good. Okay, so point slope is a form where you have a point and you have a slope. Very creative name, isn't it? So if you have point slope form of an equation and they give you a point, I want the point to be 2, 6, and they give you a slope, and the slope of this thing is 4/5, would you please write me the equation if that's my point and my slope is 4/5? I'll pause for a second while you do that. So you should have said, I'm going to stick the 2, which is the x, right there. And the 6 is the y, so it goes right there. And the slope is 4/5, so it goes right there. Y minus 6 equals 4/5 x minus 2. Now would you please multiply it all the way out and get it solved for y, and you'll have a different form of the same equation. Now just to clarify, you do not have to do this on a typical top 20 because this is a perfectly good form of an equation. But if you were asked, what's point slope? No, that's point slope. If you were asked, what's slope-intercept form, you have to know how to do it. What's wrong with that? Well, there's nothing wrong with that, really. It's just that to get it into the right form called slope-intercept, I need to multiply it out a little further and just distribute this. So I have y equals 4/5 x, and then the 2 times 4 makes 8/5, and I got to add that to the 6. It would be handy if they had a common denominator, so I'm making this 6 turn into a whole bunch of fifths by multiplying it by 5/5. That's legal, right? Just multiplying it by 1. Okay, so that makes it 30/5 plus the 8 is 38/5. Y equals 4/5 x plus 38/5. Now, could you have also said that as 7 3/5? Yeah, okay, made a mistake apparently. Yes? Is there a negative somewhere I missed? Yep, that's a -8/5. Thank you very much. Okay, so I'm not going to have 38/5. I'm going to take the 30 and subtract the 8 and make it 22/5. Is that right? All right, good. And that would be the same as 4 2/5, or 4.4. Use the decimal. Okay, so there we go. That's, what form did I just get? Slope-intercept. So there's your slope, there's your intercept. Now, we want to make you think a little deeper about slope, because slope isn't always just take 2 points and find the slope. By now, if you guys couldn't take these 2 points and find the slope, I'd have to, I'd be very depressed. So I'm going to skip that slide because you got that. But What about if your points are actually data? They're actually a temperature at a certain time. You still just find the slope. It's going to help you understand that slope doesn't just have to be how steep is this hill or how steep is this line. Slope can also be something else. I'd like you to figure out, go ahead, use these 2 points, but then read the context of the question and figure out what is that thing. When you get the answer, what is it? Act like you're explaining it to your little sister. What is that number you get? I'm going to pause while you try that.
Y minus 3 equals -9.
All right, so there we have a, given the point slope equation, we're taking these 2 points and we have put them in and we've got this equation, but some kids think, well, that's not done yet. You have to solve for y. No, you don't have to solve for y. This is a good equation. It's just as good as the other kind where you solve for y. But if they tell you your answer has to be in a certain form, what if they said answer must be in slope-intercept form? Would you please put that in slope-intercept form? I'll pause while you try that. Okay, we're back. Let's see if you did it right. Add 3 to both sides. I know I have to multiply that other thing out, but I'll try to do it all at once. -9/7 x plus 18. I'm multiplying now, so I don't need a common denominator. So 18/7 would work. And then I have to add 3. And now the 3 should really be changed into 7ths so that they have a common denominator. So I'm timesing by 7/7. And that makes it 21 plus 18 makes 39/7. I think -9/7 x plus, is it 39/7? All right, awesome. And you could make that into 7 times 5 is 35. So it'd be 5 4/7. All right, good. So why would you ever do that? Only because it's in a different form now. Slope, and what's this part called? Intercept. Okay, good. So this has just got some exploration of what if we wanted the domain and the range and stuff. Well, if it's an arrow on both ends, the domain of these is really easy. It goes forever in both directions, right? And the range on this thing goes forever in both directions. But what if you had a line that was completely flat? What's its domain? -infinity to +infinity, all reals, okay? What's its range? What if it's going across at y equals 3? What's its range? Just 3. The only thing y can be is 3. All right, how about this? And oh, wait a minute. What is the slope of a line that goes exactly flat like that? Slope is 0. Think about it. If you had a point here and a point here, and this was 0, 0, and this was like 0, 5. No, wait, that would be 5, 0. Then when you actually subtract, you get 0 over -5 or 5, and it doesn't matter because 0 over anything is equal to 0. That is a slope of 0. Now, just to clarify, some kids say no slope. Not true. No slope means you cannot find a slope. This has a slope, and what is the slope? 0. That's a big important distinction. Some kids think no slope means the same thing as 0 slope. It does not. The slope of 0 is a flat line, no change. All right, so then how about one of these? How much slope does that have? That, you could say, has no slope because you cannot get a number. If you were going to give an approximation, it's approximately infinitely steep. Infinity steep. Let me show you why. Let's say you had 0, 0 as a point here, and we had a point here that was at 0, 5. If we do the rise over the run thing, how much rise do we have? 5 over how much run do we have? See how we're going to divide by 0. Yeah, not good. What's the closest thing you can think of to 0? Like maybe 1/1000th? Even though that's not 0, it's really, really small. Do you get, if I flip and multiply that, it becomes like 5,000. So that gets to be infinitely small. The answer gets infinitely big. So if you were going to say something technically, it's not right. But The closest thing is the slope is infinity. But you should not say that as an answer on a test. You should think further and say, well, technically, the slope is undefined. There is no slope. Okay, good enough. Let's get to your homework. It looks like this. We've done enough of these so that this is pretty easy. You may skip number 5. And you may skip 14 and 15. We've done these on the top 20 so much that those are unnecessary repetition for you. On this one, I think these are actually good for you to just do some basic graphing and remind yourself how to find the y-intercept and the x-intercept on a simple graph. And then you're also supposed to find the slope, which I could see just by looking at it. But it won't hurt you to do a couple simple graphs. So do those two. This one's also good because it's one of those weird ones that either has no slope or infinite slope, and I want you to think that through and get that answer. And then this one's good too because people often get confused by that. Really, the slope on that thing, we did a practice of that. If there's a 1 there, it shouldn't be hard for you to figure out what the slope on that thing is. All right, so I want all of those done. Here's some more, and these are word problems, and this is where it actually gets like pre-calc level, where you're just starting to talk about, instead of just how steep is that line, it's making you think about things like, what if we had this line and I want to be 4 units away from that point? I'm going to give you a hint. Didn't they just ask you for a distance of 4? Don't you have a formula for that? Think back to the great big warehouse. Can you imagine the distance formula? If you can picture that little story I told you, that's helping you remember the distance formula. All right. Again, not super hard, but it says it's a 2-minute question, harder than like the simple ones where you're finding a slope. It's just a slope, though. It just happens to be a rate this time. All right. So I want you to do all these word problems. They're not hard. They should take you literally 1 or 2 minutes apiece. And then this is a skip. It's an optional challenge question. Okay. Should be one of the easier assignments that you have had in a long time. And that's all I got for the video for today. We are going to go out and do the lab where we just time ourselves for throwing the ball in the air for the tennis ball lab. If you are at home and missing this and you want to have your time for the tennis ball lab, have somebody time you with their iPad or with, I don't know, some calculators have it built in maybe, but your iPhone maybe, and just have a timing device. Have somebody time how long you can keep the ball in the air. Typical answers are between 2 seconds and 4 seconds, with the kids throwing really strong, getting that 4-second zone. And you're trying to throw up because instead of like out like a fastball, because they don't stay up very long. You want to put most of your energy into throwing it up. All right, that's all I got for you for today.